how it starts. We go back to your house.
Hi guys, my name is Nako Nakatsuka. I'm a 4th year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now I'm going to talk about molecules with multiple stereocenters, not just one. And so before we were talking about something that had one stereocenter, right? And in that case, we had two configurations, either R or S, where R goes to the right and S goes to the left. So we had two possible stereoisomers. But now, what if we had more than one stereocenter? So in this case, this molecule has two stereocenters, where this carbon, remember, also has a hydrogen attached that's not indicated, but it has a COOH group, an OH group, as well as this whole group, as well as a hydrogen. So now we have two stereocenters, and there's all possible combination of R and S for each stereocenter. And thus, you have 4 possible stereoisomers, and this can actually be written as for every n stereocenters, you end up with 2 to the power of n possible isomers. So this is a very good way to figure out how many possible isomers you can make based upon the number of stereocenters. So now let's look at this particular example, where we start out with the enantiomers, which have S and S and R designation at the 2 stereocenters, but then these two are diastereomers and these two are diastereomers. So you can create enantiomers, this first step, by inverting all the stereocenters. So for enantiomers, invert all stereocenters. So in this case, we started out with both being S, so in order for it to be an enantiomer, they both have to be R. And then you can invent the stereocenter by just switching the position of any two groups. So in this case, we had the OH here and the COOH right here, but that was switched over in this case. The same was done for the bottom. We had OH on the left and COOH on the right, and that was also switched over. So the way in which you can create enantiomers is by inverting the stereocenter by switching the position of two groups. So now, in order to create diastereomers, you can do that by inverting at least one, but not all, stereocenters. So invert one stereocenter, or let me also put in at least one, because if you had a total of more than 2, then you could invert more than one stereocenter. So invert at least one stereocenter, but not all. And so in this case, we started out with one being S and the other being S, and so we inverted one of them to get these two being diastereomers, where one is S and one is R. In this scenario, we have 2 R groups for the 2 different stereocenters, and then in order for that to become diastereomers with this guy, we inverted the other one with S. And that's why in the case of this particular molecule with 2 stereocenters, you can end up with 4 possible stereoisomers with either the SS designation, the RR designation, RS, or SR. So now let me give you a proper definition of diastereomers. So diastereomers are stereoisomers that are not mirror images. And this is a very important definition, as well as enantiomers, to remember.